Okay, I don't know how it does this. I don't know how Q4OS is successfully recording my camera and my microphone. Of all the Linux operating systems that I've tried to run on this laptop, nothing has recognized my camera and my microphone, let alone my Wi-Fi. Even my wireless card is recognized. And you know what I think? I think what the installer does when you install Q4OS from within Windows, it looks at the drivers that Windows is using and then it copies them into the Linux operating system. That's the only thing I could think because I can't think of anything else to explain how it's actually working. So anyway, I'm going to show you now. I'm going to switch to my screen capture here. And as you see, I'm still running Linux. I'm running Q4OS. Let's see here. In fact, let's take a look. Let's see. Can I look at my hardware here? Because I know there was a place. Let's see here. I know there was a place somewhere where I was able to view my hardware. There was a, let's see, system settings. Let's see, what's this here? Okay, let's see, it's showing up here. Okay, so what do we got here? Screen locking. Let's see. I want to disable the screen locking because let's see, lock screen automatically after 5 minutes. Because I'll go to the bathroom and then it will lock the screen and require me to enter my password. I'm thinking like, and actually, why ever lock my screen? Seriously, why ever? I'm home alone. Okay, so let's see, where is all this crazy stuff, man? This is so cool. There's so many things here. So look, it's connected to my wired Ethernet connection. But if you look here, this is my personal Wi-Fi network, Chastity White Rose, and there are several other Wi-Fi networks available in the area. So it's cool. So as you know, the internet works because I was able to download and install all those packages. But what I want to show you this time is I want to show you that I actually got one of my old SDL programs working. Okay, so first let's clear the screen here. And I'm going to type make. Now watch this. I type make, and you see this? I believe I showed this program. Wait, I showed that program in one of my videos, but okay, it ended. I did not want it to end. I may need to look at the source code here. Okay, yeah, okay, let's take a look at the source code here. As you see, it works. Okay, so first let's go to main.c. Main.c is the source. Okay. Oh, Paragon 1. Okay, that's interesting. Paragon 1 is the name of the function that it's calling. So let's go, because I know, whoa, normally I have to double click on these, but I'm used to Windows where I have to double click on things. Okay, Paragon 1 here. Okay, that's cool. So here we have, this is a whole bunch of SDL code. This even uses SDL GFX, which I was not using in some of my other projects, but I still have a whole bunch of code here. So this is nice. So we've got, and these are star polygons, keep in mind you. Even my star polygon routine is super quick with SDL GFX. So now, okay, here's our code here. See this code? This is what limits it by a certain frame number. Now, if I comment out this code, then it will not automatically quit after so many frames. Obviously, I had it doing that because I was trying to make a certain number of frames just for an animation. Okay, so now that I've done that, let's go back to the terminal. Let's do make. And now you see that? See how fast those things spin? I swear, they never spun that fast on Windows. They're spinning twice as fast as they did under Windows 10. That's because the memory usage here is so much less. So I'm running like KDE Plasma because it's the default desktop environment, and I don't know how to change it. But let's take a look here. Okay, so okay, first of all, let's look at the disk space. Now it's hard to read those numbers, but okay, let me just look man-df. Okay, so there's human readable. So the -H switch makes human readable. Okay, so first we're going to look at my disk space usage. Okay, so we're going to look at the disk space usage here. Okay, so here's what we have. Now, I figured this out. Now, you see where the size is 465 gigabytes? That is my internal hard drive. There's only one hard disk in this computer, but notice it says SDA2. Well, that's because according to this Linux operating system, the Loop 0 device, which is the 62 gigabytes one, keep in mind only 9.8 gigabytes is used of 62 gigabytes. That is basically my disk image. Linux runs entirely in that, and that file is an actual file within that partition that also runs 110. So dev SDA2 is my Windows installation basically, and Loop 0 is my Linux installation. I've used only 17% of my 62 gigabytes. And then notice how the other one, the Windows 10 one, is mostly full. Well, that's mostly all my music and video collection from iTunes and all sorts of crazy stuff filling that up. Plus the fact that the Linux is inside that Windows, so that space may be accounted for double. So that's disk space. Now let's look at the amount of free memory. Okay, so free-h here. Okay, so according to this, I have total of 3.7 gigabytes of memory on this machine. Now, I'm not sure the way it's calculating. It might be using multiples of powers of 1,000 to base it on. I'm not sure, or it might be doing some other measurement. But so it's saying 3.7 gigabytes, and I'm only using 727. Let's see. Yep, it's still the same results. So I'm only using 727 megabytes of out of my 3.7 gigabytes of memory. So less than a gigabyte total I'm using with the whole desktop environment here. And it's using 45 megabytes of swap. Oh, actually, let me try something. Now, okay, now whenever you're trying to look up information about a command, you do man and free. Like, okay, so let's see. So, bytes, kibby, mebby, gibby. Gibby? What's the kibby and mebby and gibby? That's weird. That's not what I'm used to. I'm used to, okay. There must be a different measurement because I'm not used to. Okay, let's try giga. Okay, let's try. Okay, free giga. Wait. Oh, it has to be. Okay, yeah. We want it to be. Okay. Okay. So now it's just saying 3 gigabytes, use 0. Well, that's not very descriptive. That's really not very descriptive at all. Let's try, okay, yeah, let's try mega instead and see if we can get a better reading here. 758 megabytes of memory used. Yeah, freaky. So the memory usage is very minimal. It's super fast. So when, let's see here. So when I run that program that I just compiled, it's super fast because the CPU and memory usage is just so low. Okay, so now let's see. I got that program working. Let's try running some of my other programs. Okay, let's go to cd blank check. Now this here, this is a special project I did. Where I wrote the exact same program, an empty program. It's called blank check because I'm writing basically a blank program just to check to see if it works. Let's do cat makefile. Let's look at my makefile. Here I have, Oh, I didn't include a new line at the end of that file. Big deal. Okay, so we have if I we have for SDL1 and SDL2, and I have static versions as well. Okay, so if I do make, notice a window pops up. This is the SDL1. This was written in SDL1 version 1.2. So it's the same. If I do SDL1, it's the exact same thing. And if I do SDL2, then it's the exact same thing, except it's with a different version of SDL. So, in other words, these programs do absolutely nothing. The only thing they actually do is that I press escape, they end, and if I click the X, they end. So let's just take a look at the source code of those two programs. Okay, first of all, I have to figure out how to get up a level. Okay, yeah, I'm a little bit lost here. Okay, how do I... Okay, I know what to do. Okay, I just will go back here, and then I'll go down to blank check. Okay, so I'm going to view both of these files. Okay, so there is SDL1. Okay, so this is a very short program. You see all that? This uses the original SDL library. The version 1.2 is the final edition of that kind. And you see it's got everything. It creates a window, it fills it with medium gray, and then it does a loop that continues until I press escape or click the X. So I'm a very experienced SDL programmer, but more with SDL2, the modern version. Now let's look at SDL2. Let's see how it looks. This is the exact same thing. The syntax is different. Names of a few functions have been changed, but it's pretty much the same. Okay, let's see if I can compare those two side by side. Okay, that's very weird because as soon as I open... Oh, wait, what? Oh, wow, what the... Oh, that's freaky. But how do I view these side by side? Like, how do I... It seems like each one wants to open a whole new window, and I want them to be in tabs so I can easily switch between them. I don't know how this works, and of course I can install other text editors. There's no doubt about that. But okay, just for the sake of example, okay, this is the text editor, kwrite. Now let's see if this is customizable. Let's see. I know that there's a way to customize the way things look. There is, every text editor has a preferences or something like that. But, you know, that would take time to figure out. Okay, so we've seen that my SDL 1 and 2 programs compile. You saw the other one. Okay, so now let's go. Oh, wait. Okay, wait just a minute. I went all the way back to my home directory here. I did not mean to do that. Okay. So what I'm going to do now is I'm going to navigate 0SDL checker roll. Now checker roll, this is the one that has Twilight Sparkle. You see the images for Twilight Sparkle there? I can even double click on this and then I can view them, although they don't look quite right because this program doesn't zoom in on them correctly. That's just weird. What in the world? There's probably a better way to do that. That's just weird. It scales it wrong. Anyway, okay, let's go back to SDL checker roll. Okay, so this is the place. So here's how I'm navigating. So here is the path to it. So I copy that and then I do CD and then I right click, Control plus Shift plus V. That's one way to do it. Okay, but I just did it by clicking. Okay. It also works when I do Shift and then Insert. That's another way. Okay, anyway, I'm in the correct directory. Let's try make and see if it compiles and runs. Index redeclared as a different kind of symbol. Okay, this never happened on Windows under MSys. So let's see now. In file included from user include SDL inc SDL main SDL H. Note, a previous declaration of index was here. Extern care index const care. So in other words, user includes strings. So somewhere in either the C-Center library or, oh, this was included in SDL. It's not part of SDL, but somewhere there is a global variable named index that conflicts with my variable. Now that did not happen on MSys. I swear it did not, because I compiled this program on Windows in so many videos. So here's what I've got to do. And I don't like the interface of this because I'm not used to it, so that's just because I'm not used to it. Let's see, what does this do? This was a batch, yeah, see, this was a batch script. This is meant to run under Windows and run a very specific command here. Okay, we don't need that right now. Okay, what I need to do, I have to correct this error. So main.c, this was my, now I could try to edit this in Vim, but because I'm still not used to Vim yet, that would take more time. So I'm just using the default text editor, and I hope it's readable still for people. Okay, so all the code's here, but now index. Okay, we have global variables named index. Now, where is the index variable actually used? Okay. Oh, I noticed something. Wait a minute. Oh, I need to close that. I need to close that and then reopen it because I accidentally changed something without meaning to. Okay, when I noticed something. Notice how as soon as I did Control F to do find, it is trying to include. That's because my cursor was on that. Okay, but here's what I'm going to do. Let's go to index, and okay, it's still being weird. So let's find index. So index appears there and in index 1, and then it's used extensively in the checkerboard function. Okay, so that's the only place where index is actually used, is in the checkerboard function. So here's a general rule for programmers. If you have a variable name that's only used in a single function, yes, then it's time to make it a local variable. Okay, so what I'm going to do here is I am going to move this. Okay, so let's do this. So let's cut those from there. Let's not make those global, and then I'm going to simply okay. All right. So now, and then we have int index. Okay. So yeah, we've got it. Wait a minute. That's just very weird. Why is it? Oh yeah. Okay. I guess everything's all right. Okay. So now that we have, oh, we need to put a semicolon there. Okay, you see, index and index 1 are only used here. Index is first sent to 0. This is my famous checkerboard routine. I'm famous for drawing checkerboards using computer programming languages. Okay, so index is set to 0. 0 represents black because of the color palette that's set up. Or actually, I think it's like magenta and green, because I can set them to anything I want, to those colors. So it's set to 0, and then index 1 saves the value of index, and then it alternates it through that row and all that stuff. Okay, yeah, you see my checkerboard stuff. It's just very pretty seeing it in Linux. Okay, so now let's go back to the terminal. Let's type make. Ooh, wait a minute. Oh, libm. Okay, I got this error earlier. Undefined reference to sin at glibc. Now, that's not referring to the Christian concept of sin. That means the trigonomic function sine is what that means. Okay, so here's what I have to do. I had to do this with another program. So I need to edit my make file. In order to get this to work, it is required, for some reason Windows didn't require this, but it's required on Linux to include the math library, which means it's just LM. So LM there. So I'm going to put LM both there in the dynamic compiling one, but also here in the static compiling. Okay, so now that I've done that, let's see if I can get back to the terminal. Okay, make. Yeah. Ooh, freaky. Okay, you see this? Now you see how slow this is. You see how ridiculously slow this star polygon thing is. We got a black and white checkerboard, and that's fine. That's totally fine. But it's very slow. It's nothing like the speed of my SDLGFX. That's because I didn't use SDLGFX. I did something very different. Okay, so, but what I'm going to do here, okay, wait, I need to go back to, okay, there's the make file. Okay, may not see. Okay, so what I'm going to do is I'm going to temporarily disable the star polygon thing here. Okay, yeah. Yeah, and I tried to do a fast star polygon, but as you see, it's still slow, so it was useless. Okay, we're just going to enable just the regular polygon surface. Okay, and that is just a regular polygon, so it's a whole different matter. So let's see here. Okay, as you see, it's faster. It's not as fast as the SDLGFX, but we have an octagon, and it's very nice looking. It's cool. Now, some of it is covered up by the menu at the bottom. I don't know if there is a way to hide that menu. Let's see here. Panel options. Configure panel. Let's see here. More settings. Auto hide. Okay. Okay, yeah, there we've got it. It just like in Windows, you can customize it to auto hide itself. Okay, so here's what we've got. I can move the checkerboard, and whenever I move the checkerboard, the octagon also spins. But the same is also true when I move Twilight Sparkle. So yeah, this is super cool here. Yeah, and it still is the same way it works on Windows. So it still works the exact same way. It's just ridiculously slow because as soon as I added the polygon to my program, it slowed it down. That's why I need to do one of two things. I either need to draw polygons using my SDLGFX method, which requires a whole lot of special code for that. I had to it's a total rewrite if I was to do it that way. I have the code I need that I can copy and paste, but I have to go into several different files and copy and paste several different portions of code. It's really kind of a mess. Okay, but I'm just gonna try to show you real quick. Okay. Also, I want to see what happens if I try to do my make static build. Okay, make static. Okay, let's see. Using DL open in statically linked applications requires at runtime the shared libraries from the glibc version used for linking. Cannot find LA sound. A sound. What is a sound? That's strange. Well, let's see here. Wait a minute. Okay, here's what I'm going to do. Let's do an apt. I know how to use the package manager from the command line. Okay, so apt search a sound. Let's see here. Apt search a sound. Okay, let's see what we've got here. There's a whole bunch of stuff here. So okay, lib a sound. Lib a sound. Dev. Okay, so let's do. Oh, okay. Lib a sound 2.dev. Okay, so let's do apt lib a sound dot dev. Okay, wait. We want to do apt install libasound dot dev. Wait. Oh, okay, I see. I have to do sudo. Yep, sudo. Okay, yeah. And it asks for my password whenever I install software. That's strange. Selecting. That's strange, but why was it saying it can't find libasound? I'm not entirely sure. In fact, just to see, sudo synaptic. Okay, let's try this. Okay, because I want to know what it's saying about libasound. Well, it's got all that stuff in there. Well, I don't know. Well, it dynamically links, so who cares? As long as I can compile and run it on my Linux machine, that's the main thing. But it needs a speed improvement. In fact, I'll show you something else. Oh, I was going to just show you one thing though. Is I was going to show you the file with the code that makes the polygons work. This is big code. I've got global arrays for the polygon. I have all the variables defining a polygon. Function that gets the points, the function that fills an image, that draws lines using the Bresenham method, that draws a polygon using the lines. Then I've got another one that uses a scan fill. So it uses tons of function calls just to do one polygon. Nowhere near as fast as the GFX method. And I also did another example that I'm going to show you. Okay, let's see here. Okay, so let's go to cd polygon tests. Okay, SDL. Okay, SDL underscore BBM. Okay, so. Okay, yeah, I have to add the math library to this too. Okay, let's try something. Vim make file. Okay, this time I am just going to do a quick edit in Vim. So I know where I need to go. I'm going to go here, and I'm going to -LM, and then I'm also going to add it here, -LM. Very interesting. Okay, that's cool. So now that I've done that, okay, let's write quit. Okay, so let's try this again. Now you see this, you see how this is, okay, this is just a triangle, so it's relatively fast. And of course, it actually quits after a certain number of frames. So it's kind of weird. But it's faster than the other because it's just drawing a black screen and then doing a white triangle over. It still uses all the same code, but less is running. Okay, wait. Let's see. Okay, actually, let's do vim make again. I just want to read that. Okay, yeah. So I'm going to just try for the fun. Let's do make static. Static. Seeing if it works. Cannot find LA sound. That's very strange. Actually, let's try something. I'm just going to try. I'm going to try a different compiling command. See, this is just technical details. Technically, this doesn't matter because I can run my program, but I just want to see here. Okay, so LA sound. Yeah, I don't get it. I don't know why it doesn't work, but it's not a big deal. It's really not. Okay. Okay, CD. Okay, CD. Okay, yep, and one more time. Okay, now we're at this folder. See, I know my area. This is the same environment, the exact same folders I use on Windows in MSys all the time. Okay, now we're going to go to GL. Let's try something. So first, let's go to foo. I named this foo because this is a lazy foo tutorial lesson. Make. Cannot find L OpenGL 32. Cannot find L glue. Cannot find L free glue. That's very strange. Yep. That's weird. I know things are strange on here. I'm pretty sure there are separate instructions for compiling the Linux code. So I'm not sure. Let's go to my temp directory and let's do make. So that's weird because I've got cat make file here, and this was one. Now this completely compiled and ran under Windows, but it's not running under Linux, and I don't know exactly why. So I'm going to have to research this and do some searching. In fact, let's see how long I've been recording. First, okay, let's see. Let's go to. Okay, wait. I can. Wait, okay. Wait. I don't know how to navigate this very well. Okay. Let's see. Where am I? I can. Okay, I can get out of that. Let's see. What have I been doing? So, I have been recording for about half an hour. Let's just go, let's look at the lazy foo tutorials. That's what I'm going to do. So let's go, I've got Google Chrome running on Linux. This is actually super sweet. So let's just load up my web browser and let's see if I can find what compilation flags I have to use. Now, some people seem to think that just looking for a quick solution online the way I do, is kind of a lazy way and you're not learning things. But honestly, if there's another way to find out which compilation flags to use on which operating system to get your C compiler to compile things, I don't know of another way other than just Google searching. I don't even know how lazy foo figured it out. I don't get it. Okay, wait, let's see here. Lazy foo SDL. Wait, no. Oh, it's the lazy foo OpenGL. Okay, because this person, whoever they are, has OpenGL tutorials. So let's start out. Introduction. Okay. Yeah, rendering polygons in 2D. See, because I'm trying to learn how OpenGL works because I might be able to use a lot of OpenGL stuff as a replacement for using my own code for polygons, or even using SDLGFX, because I don't want to add all the other unnecessary stuff that comes when I have to compile a link into SDLGFX code. I'd rather just use OpenGL because it's standard and fast. Okay, so anyway, let's get started with OpenGL. So first, okay, so now this is, okay, let's see. This is the information I'm looking for. Okay, needs to be able to find the header files, blah, 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 because we're using free glute here. We're using all sorts of stuff. So, okay, first is the setup. So, I already follow the directions on Windows. That's how I got the flags that I did use. So, I'm just going to go to the Windows one, though, and show you, because what I did is I went to the Mingwei one, or MinGW, I just call it Mingwei, I don't even know why. And then, setting all that up, and then I looked at the, see, this is how I got it working. See, I got all of that stuff working. OpenGL, LGlue32, and LFreeGlute. So that's where I got those flags, you see. And I don't actually use these part of flags because when I was on Windows, I was actually using a Linux type of subsystem, the MSys system. So when you look at my makefile, you'll see that I was using OpenGL32, LGLU32, and FreeGLU. And then some of this other stuff here, that was what I found from a different tutorial actually about static linking. So it was super cool. So those are OpenGL32, LGLU32, and LFreeGLU. So yeah, that's the exact same as what we have here. So that's cool. But we're going to be looking at different compilation flags is what we're going to be looking at. So now I'm going to go back to the previous page, and then I'm going to go back to the previous page, and then we're going to go to Linux because now I'm on a real Linux distribution. Now, let's see here. I am pretty sure that I actually have FreeGLU and all that installed. I just don't know the exact thing. I just don't know the exact flags, but I'm pretty sure I already pre-installed it before I started recording this video. And see, they have code blocks instructions, but I hate using an IDE. I have to know the exact command line things, or I can't script them. I can't write a makefile, so I always have to know the exact things. Okay, here we are. This is what I'm looking for right here. Can I make it bigger? Yes, here it is. I'm making this bigger for the purpose of this video. Setting up FreeGLU on G++. Okay, this is it. So, okay, now I already know that this just turns off warnings. I don't need that. What I need are these things. We've got LGL, LGLU, and LGLUT. Okay, that's very weird. Okay, so what I'm going to do here. Okay, so now I'm here. So let's go. I need to go to this folder. Then let's go to the GL folder. So now let's go to my makefile. I'm going to open my makefile. Okay, and here's what I'm going to do. Since these these were what ran under MSys. Okay, so what I'm going to do, I'm going to copy and paste that, and here's what we're going to actually do. Now, let's do okay, I don't yet for sure know precisely what's going to happen. Okay, so this this is going to be win OpenGL. Okay, win OpenGL static. I'm going to replace those with names that begin with win. Okay, so that's good. So now, yeah, this is crazy. Okay, so but we still have okay, wait. So we've got I haven't saved the file yet. Oh, wait, let me go back to that. Oh yeah, this is crazy. Okay, have I saved the file? Okay, let's make sure it's saved. Why is this not reflecting my changes? Where am I? Where am I? Oh, wait a minute. Oh, I'm in the wrong... Oh, wait. I'm totally in the wrong folder. Of course, I'm going to update that makefile as well, but that's the wrong one. There's not even any source files in this one, so why is there a makefile here? Okay, that's just weird. Hey, wait. Oh, I hate it. I'm used to just clicking it to select it. Okay, let's delete that. Yeah, the interface and the way things are clicked is different here. Okay, so now let's open this makefile and let's do to this file what I was attempting to do to the other one. Okay, so we've got win OpenGL there, and we've got win here. And we're going to assume that anything that doesn't begin with win is going to apply to Linux. Okay, so what we have now is we see that file is updated here. Now we need to change this. This is OpenGL32, lglue, and freeglute. Okay, so let's change that. Let's change that to these flags instead. So we've got lgl, lglue, and lglute. Okay, let's try that. So now let's change this to these. Okay. Let's see if we can get it working. So first we change it, now make. It works. It works. We have Chastity Square. It actually works, people. Isn't that the coolest thing ever? Now, one little tricky thing that I can't help but wonder. Okay, now we see that it does this, but what happens if I try freeglute? Okay, let's try putting let's try putting lfreeglute. Lfreeglute. Cannot find lfreeglute. When it's just plain glute, it works. So I guess freeglute is not called freeglute on Linux. It's just called glute. Isn't that just the weirdest thing you ever saw? Yeah, that's just weird. Yeah. Now I wonder what happens if I try static. Wait, let me look at this makefile. Okay. Yeah, that's weird. That's very weird. Yeah, I'm gonna try something here, because I'm going to see well, you know what? I don't really know. I'm not going to worry about static builds necessarily, because okay, yeah. Well, I'll leave that there for now, just in case. But I don't know if it's actually necessary, because as you see, we type make and the square appears. Now, I've been meaning to modify this source code. I've totally been meaning to modify this. That's what I was working on, but then I was installing Q4OS. But it draws a square, and it's Chastity Square, and that's very precious to me. So, and then when I just do /main, the same thing appears again, because we have a program here that just runs. So what happens if I just click this? Oh, you see, it works. All I do is click it and it works. You don't have to worry about statically linking things on Linux anyway, because all the shared libraries are in the correct places your operating system looks. So I can right click this. Yeah, I can right click it. It's strange. It doesn't have an option to run, but when I just left click it, it runs. So that's cool. Now what happens if I left click main.exe? You see this? This is a DOS/Windows executable, and it does not run. This did run on Windows, but I'm not on Windows. I'm on Linux. So let's delete this, and I can do that. But see, I can also select this, and I can delete that, and then it's gone. But it doesn't matter if I delete that. Why? It won't run now that it's gone, but I just do make, recompile, and it works. So that's the thing, is now I know the correct method for I can compile my OpenGL programs and my SDL programs on Linux, dual booted with my same computer that runs Windows 10. Oh, this is just amazing. So I'm very impressed with Q4OS. I'm just super impressed here. So now that I have that done, I probably am going to need to back that up. It's good thing I record this video so that if I compile things in Linux and they give me things about me not including the math library, or if they give me errors about not being able to compile my OpenGL programs, I know what to do from there because I have this video to reference. So yeah, this video is getting kind of long, so I hope somebody has enjoyed that. The fact that I can now record programming videos on Linux on this laptop is amazing. And this laptop is still pretty old, but I've got a really nice setup here. And I could even switch to other desktop environments other than KDE once I learn how, and the performance might be even better because KDE is kind of a big desktop environment. It uses more memory than some others, so I need to mess around with Linux before I record more videos, but this is just kind of an introduction that I can program on Linux now. It's cool.